In this video, I will explain how to solve a projectile motion problem in physics that involves a plane dropping an object. So let's jump right into an example. This says, a rescue plane flies at 55 meters per second at a constant height of 500 meters. If the plane wants to drop a rescue package on an island, how far in advance should the package be dropped? So I've gone ahead and sketched out this situation. So we have this plane that's flying here with an initial velocity of 55 meters per second. We also know that it's flying at a height of 500 meters. And we know that the package is going to be dropped and it's going to fall through the air and it's going to land. We want it to land right here at the start of this island. So the question is, how far in advance should the package actually be dropped? So what we're really trying to find is the displacement in the x direction. So we're trying to figure out what is this x value. So the formula that we need to know to solve this is that x, the displacement, is going to be equal to the initial velocity in the x direction times the time. So the time, that's the time that it will take this package to actually hit the ground once it's dropped. So right now we know the initial velocity, that's 55 meters per second, but we don't actually know the time. So first we need to figure out what is that time going to be. And the formula to find that out is y minus y0. So this is the displacement in the y direction. That's going to be equal to the initial velocity in the y direction times time. And to that we have to add 1/2 times g, which stands for the acceleration of gravity, times time squared. Now we need to know that the acceleration of gravity, this value right here, this g, is negative 9.8 meters per second squared. That's the acceleration of gravity that will be acting on this package when it's dropped. So let's go ahead and solve this equation. So this y value, this is our ending y value. So if we say that the ground right here, let's say that's 0 meters, that's going to be our final y value. So that will be 0. And our initial y value, our y0 right here, that's going to be 500. So we're 500 meters in the air. So we can go ahead and fill in, we'll say 0, our final y position, minus 500, our initial y position, must be equal to, now this is really important, we need to understand that this initial velocity in the y direction is 0. Because remember, this package is just being dropped from the plane. So there is no initial velocity in the y direction. So this is going to be 0 times t. And then we'll have plus 1/2 times, again, gravity, that's negative 9.8. And then we have t squared. So this is pretty straightforward to solve for t. So we'll get negative 500 is equal to, this is just 0. 1/2 times negative 9.8, that's negative 4.9. And then we have t squared. So to solve for t, let's divide both sides by negative 4.9. When we do that, these negative 4.9s cancel out. We're left with, on the right-hand side, we have t squared. On the left-hand side, negative 500 divided by negative 4.9, that turns out to be 102.04. And to solve for t, we're just going to take the square root of both sides. And we'll find that t is equal to, that turns out to be about 10.1. So we'll say seconds. So it will take 10.1 seconds for this package to actually hit the ground. So now that we know this t value, we can jump back up here and figure out what is x. So we'll say x is equal to the initial velocity in the x direction. That's 55 meters per second. So we'll say 55. And then we're multiplying that by the time, which we just found is 10.1. And when you multiply those two together, you come up with 555.5. And we'll say meters. So that is our answer for this one. This package needs to be dropped 555.5 meters in advance of the island in order for this package to actually land directly where the island starts. So that's how you can solve that type of problem. You really just need to know these two equations right here. As long as you know these two equations, then you can always solve this type of problem that involves a plane dropping an object in a specific location.